Hi, this is Paul Rao with Technically Speaking at Source Allies. Today we're going to talk about JavaScript asynchronous methods, async await, promises, generators, and callbacks, why you use one over the other, a little bit of the history, and how they kind of work under the scene. So I have a JavaScript file here, a JavaScript project, and in Node.js specifically, it became really common to have to do asynchronous tasks that were non-blocking. A really common one would be like reading a file or making an API call. And there's a bunch of different ways to do that historically have different reasons for existing. So let's say we have a JavaScript project here and we want to read a file. For example, if we want to read the package.json file that I just showed you, this is how we would do it in Node.js. Back when Node first came out, we would import the read file function, we'd call it, and because it's asynchronous and non-blocking, we can't wait for a return value. We need to actually let the event loop cycle. So instead, we pass a callback method. By convention in Node.js, these callbacks take an error as their first argument, and whatever the result of the function is their second argument. So in this case, data. Then us as the client, we have to check to see if there's an error. If there is, we're just logging it here. And if there's not an error, then we can do whatever we're going to do with the response of that, in this case, the contents of the file. So if I run this particular script here, you'll see that down here in our console, you'll see that it says starting, it says done, and then we get the contents of the file. And that's because this line executes. Then this line executes, but the actual file isn't read yet. Then done executes, then the file is read. So that's fine. But let's say we wanted to do it to a bunch of different things. So this kind of starts to illustrate some of the issues with using callbacks for asynchronous programming, and that is this concept of callback hell. So what we're doing here is we're reading the same file, we're parsing the JSON, and then I'm grabbing the main property and then going and loading that file, which is this index.js here. So I have to do these two things sequentially. They're both asynchronous and they're interdependent. And you'll see here this is a lot more complicated for something that should be pretty trivial. We're reading the file again, but then because we can't put the next read file down here on line 21, kind of where we'd want to put it, we have to wait for the first files, or we actually have to nest it inside the callback to this first read. We have to check for it having errors. Then we can log the contents of that second file. And then I moved our done up here because now if I want to actually print out a done message when we're really done, I actually have to bury it at the bottom of this callback hell once all of these callbacks have executed. So if we run this command, you'll see that we get starting, we get the contents of package.json, we get the contents of index.js, and then we get done. So it works, but it's 20 lines of pretty hard to read code, and we're only doing two trivial things here. You can imagine if we were doing more complicated stuff with business logic buried in here, it would get pretty ridiculous pretty quick, hence callback hell. As a community, JavaScript came up with a couple of ways to solve this problem. The most common was this idea of a promise. So having an asynchronous function, instead of returning the data, still can't do that, can't change the way JavaScript works as a runtime. What we can do is we can return an object that will promise that it will get you data or an error at some point in the future. Then you could take that promise and then say, hey, once this thing is done and I have data, then do this other thing next. And those are called promises, or sometimes they're referred to as venables. And was several different promise standards that came out of the community with various libraries that would implement this. And the way that would work is something like this. So the first thing we have to do is we have to promisify our function. So we have this read file function here. And what we want to do is we want to create a new promise. And we still want to call read file. We're going to pass it the path we're reading. And then if we get an error, we're going to reject the promise. And if we get data back, we're going to resolve the promise with that data. So by implementing this little bit of a shim, we now have this structure. This does the same thing. So we call promisify read file package JSON. We chain dot then we do this, then we do this, then we do this, then we do this, then we do this. So we're building up this chain of functions that are going to execute in order. And we have this nice advantage here that we get a lot better error handling. Then we'll only execute if the previous steps are successful. And if they error, then it's going to go all the way down here to this catch method. This function, if we run it, we get the same results we just saw because it does the same thing. But I will call out here, there's a couple of little nuances here that can trip people up. One is error handling. Error handling there's two definitions of an error here. So we could reject with an error, or we could throw. We could still throw an exception. Say we mistyped something, some type of syntax error like that. So in order to get around that, if we were to just call promisify read file here as our very first call, and let's say this thing just threw an exception, then we wouldn't actually end up in this catch block. We'd actually end up not executing any of these .then calls, and the JavaScript engine would immediately return from line 18. So to get around that, we can resolve a promise, just create a new resolve promise, and then chain stuff off of it, which is kind of weird and awkward. And then this also is not the most readable. It's still not the most readable code, especially if we're doing 2 or 3 different things. Then we have to use the results of all 3 things. You have to kind of pass stuff along in some sort of object payload that'll include everything. You can't just down here. I can't just reference something from package data down here in like line 27. I have to actually pass it around. So, is there a better way to do it? And turns out there is. So to do that, we need to dip into a seldom used feature of JavaScript, and that is generators. So a generator is a function where you have an asterisk at the end of the word function, the function keyword. And what it is a suspendable function. And what that means is that it can be executing, and then at some point in the middle of the function, it can halt execution, return control back to the caller, and then subsequently resume execution from where it left off with all of the internal state of the function. So, for example here, the way that's implemented in JavaScript is we call getValues. This returns an iterator, not the result. So it's not going to execute any of this code when we call it. It's instead going to return an iterator. We can then iterate over that iterator, and every time we grab the next value, we'll get back whatever we yield. So in this case, we're going to get back 1, then after 1, then 2, then after 2, then 3. So if we run this, you'll see we get val1 after 1, val2 after 2, val3. So why is this helpful? Well, since promises are simply objects now, where we need to chain them all together, what we can do is we have a generator that instead of yielding integers like we are here, it can yield promises. So we could say, do some work, yield the first promise, then with the results of that promise, do more work, yield a second promise, yield a third promise, etc. We still need a little bit of boilerplate, so we need something that just loops through the promises, just waiting for them to resolve. But, we could do that, and then we get a much, easier to understand and follow piece of code. So let's look at what that looks like. So here's that code here. We still need to promisify our read file. It turns out that Node actually has a built-in utility to do that, what we were doing in the 2 files ago. So I just went ahead and called it here to get our promisify read file. And then our do work uses yields here. So this does all the exact same thing that we did 2 files ago. We're still reading that package JSON and then reading the main, but it's a lot more readable. We're getting data here. We're yielding the promisify read file. We're parsing it. Then we're yielding the promisify read file of the next method, getting that data, and then we're calling done. So this is extremely readable. It reads like sequentially executing code, synchronous code. And here's the little boilerplate we need. So this, we grab an iterator, and then what we do is we just loop over recursively calling as long as we get back a result from next, then If we're done, then great, we're done. We just return the value. But if we're not, then we go ahead and resolve that value and chain the next promise onto it. So this code here just chains this promise back and forth and back and forth and back and forth. So if we run this, we'll get the exact same results from a few times ago. So, and you'll see we have those various steps. So this is great. This is pretty good. And in fact, if if we genericized this a little bit, it would actually be pretty readable. And this is actually what Babel would convert async await into back before async await was natively supported by browsers and Node.js. So next, let's talk about async await. So this is okay. It's fine. There's actually a non-trivial amount of overhead to this in the runtime. So we can actually go even further, and that's async await. So this is the most recent way to do this. And this is the entirety of the thing. Await is a keyword that will take whatever's on the right side of it, execute it. If it's a promise, it will wait for that promise to resolve before returning. And the way that's implemented in Node.js, the V8 runtime, and Chrome and Chromium and those browsers, and I can probably assume similarly in other runtimes, is this uses not generators, but suspendable functions. So this becomes a function block that is suspendable. It can run to a certain point, suspend execution, and then once that promise resolves, resume execution. Now, how this works internally is very complicated. And there's actually this really good blog post that I'll go ahead and link to that is from the V8 team that actually talks through a lot of these concepts. So, and it has some performance benchmarks in here because some people would say async await code is slow, you shouldn't do it, you should use promises because reasons. And while that was maybe the case in certain, niche scenarios at certain points in time, if we scroll all the way to the bottom, there's a very long explanation that talks about exactly how internally it uses promises to implement async await. We'll find the kind of the TLDR at the bottom here, which is simply just use async and await. It's going to be faster. It's going to be easier to read. And as they update Node.js, or I should say as they update the V8 runtime, they're able to do more and more aggressive optimizations because the language interpreter sees what you're doing. It doesn't just see a bunch of random method calls. It actually knows, hey, this is asynchronous code. I need to await this, and it can schedule things accordingly and push things lower and lower to the metal. So that's an interesting blog post, and we'll link to that in the video. So this is the final implementation here. Unlike previous implementations, we don't have to do anything special with error handling. We just simply wrap stuff in a try-catch because await, if the promise that it's awaiting rejects, it will throw the error that was rejected. And if a asynchronous function throws an exception, it will return a rejected promise. So this allows us to have a very consistent and predictable error handling strategy, and all of our code is nice and sequentially in line and reads like synchronous execution. So hopefully this gives you a little bit of an overview of async await, why it exists the way it does, why you might see older code that uses other ways of doing asynchronous programming, and kind of the history of how we ended up where we are as a JavaScript community. This has been Paul Rao, Technically Speaking at Source Allies. Do you have a topic you want to see covered? Comment it down below, or check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.